500 ml of 1 molar H2C2O4, 100 ml of 2 molar H2SO4, 40 grams of NaOH are mixed together. Now 30 ml of the above solution is titrated with standard solution of sodium carbonate of 14.3 grams per 100 ml of solution. Find the volume of carbonate used for complete neutralization. Check it out. If you have been given, first we'll write the data about each one, and the data about H2C2O4 and H2SO4 and NaOH. We have in the solution H2C2O4. Then we have H2SO4. Then we have NaOH. All the three are in the solution. How much H2C2O4 is there? Check it out. 500 ml 1 molar. So valency factor is equals to 2. Valency factor is equals to 2. Here, now when you take this particular one, if you want, we can write here also 1. So here normality is 2 times the molarity. Normality is 2 times the molarity. Here normality is equals to molarity. Now we have the data which is given is, let us come back, 500 ml 1 molar, 100 ml 2 molar. So we are taking this particular one, 500 ml 1 molar, 100 ml 2 molar, 2 molar, and 440 grams of NaOH. 40 grams. This is all the data what we have with us. Having this data, first milli equivalence of H2C2O4. Milli equivalence of H2C2O4 will be equals to 500. 2 into 1 into 500, that is equals to 1000. Milli equivalence of H2SO4, which is equals to 2 into 2 into 100, that is equals to 400. Now milli equivalence of NaOH, that is equals to weight by equivalent weight into 1000, which is equals to 40 by 40 into 1000, which is equals to 1000. Now you know overall milli equivalence of acid is 1400. This is milli equivalence of base. Now you know milli equivalence of acid is greater than base. Milli equivalence of acid is greater than base. So what will be the resultant normality of the solution? If I have to take this particular one, resultant milli equivalence you take, resultant milli equivalence of the solution. What will be the resultant milli equivalence of the solution? Excess acid will be left out. So there will be excess acid is left in the solution. Excess acid will be left out in the solution. How much is it? So the milli equivalence of excess is equals to milli equivalence of acid minus milli equivalence of base. Acid minus base, which comes to be milli equivalence of acid is how much? 1400 minus 1000, which comes to be 400. Now just see here, we have taken from this particular one only some 30 ml of solution is taken. 30 ml of solution. Now you know particles, number of particles in a given volume of solution, when you are taking the milli equivalence for the given volume will differ when you are taking some amount of solution from that particular one. Now you have originally 600 ml solution, you have 500 from H2C2O4, 100 from H2SO4. In 600 ml you have 400 milli equivalents. But from this, if you have taken a small amount of some 30 ml, how many will be the milli equivalents in this? So this will be 30 milli equivalents in 30 ml solution is equals to 30 into 400 by 600. So 3 twos, 2 twos, 2 threes, 30. This is 2 times, 3 times, 10 times, 20 milliequivalents. So milliequivalents is 20. Now you know this is the milliequivalents of acid in 30 ml, excess of acid present in 30 ml, and this is utilized for completely neutralizers. This completely neutralize. This will completely neutralize. Now the question comes here. It will neutralize 14.3 grams of Na2CO3 10H2O per 100 ml solution. Then what is the volume of this solution is the question. What is the volume of this solution which is completely neutralized? Now we need to find this is equals to what normality. First you have to find this is equals to how much normality, then we'll find out that particular one. Now normality is equals to weight by equivalent weight into 1000 by volume in liters. We know Na2CO3 10H2O first, equivalent weight is equals to molecular weight by valency factor, which is equals to 286 by 2, which is 143. This is the equivalent weight. Now substituting this in the formula, which is given weight is 14.3 is given, equivalent weight we got 143 into 1000 by volume is given 100 ml. So this is equals to 1 normal. So now when for complete neutralization we know milliequivalents of acid is equals to milliequivalents of base. Milliequivalents of base. If I take this concept, milliequivalents of acid is 20, which is equals to volume into 1. This is equals to volume into 1. So that means volume will be equals to 20 ml. So what is the volume of carbonate that is utilized in the process is 20 ml.